Class, sometimes in chemistry you want to measure something, a property, that is not easy to measure. That is, it's something that's conceptually not complicated, but that it's hard to do a single experiment to determine by a direct measurement. And so an example that we're going to do in this experiment is we're going to burn magnesium. So we're going to take magnesium ribbon, I have here, and we're going to light it with a torch to get it going, and we're going to burn it in air. So it's going to react with oxygen in the air. And we want to know, our goal is to find the enthalpy change that for that reaction, either how much thermal energy is released or how much thermal energy is absorbed. Well, we're going to be burning magnesium, so it's pretty clear that it's going to be exothermic, and it will be losing, it'll be releasing thermal energy. So our goal is to do that reaction. So first we're going to do this reaction directly to show it to you, and then we'll talk more about what we're going to do to determine the enthalpy change for the reaction. Okay, so what we've got here is we've got our strip of magnesium. We have a watch glass that's going to catch our product. We have a pair of tongs to hold the magnesium, and we have a torch. It's actually a creme brulee torch that I grabbed from the kitchen at home. And what we're going to do is we're going to hold the magnesium away. We're going to go ahead and light the torch, and we're going to light the magnesium on fire. Kind of on fire. The flame from the torch is going to ignite the magnesium, which is going to burn. So this is the magnesium reacting. And if you look at this directly, it's really, really bright, so that's not good. So don't watch this directly if you get a chance to. And what's happening is we're making a white solid as the product of this reaction. And you can see it evolving at the bottom of the magnesium as it reacts. People make flares out of magnesium. Oh, it stopped. Okay, that's okay. So it didn't react all the way, it fell off. And our product is this white solid, which is magnesium oxide, which has the formula MgO. Magnesium makes 2 plus ions, oxygen makes 2 minus ions, so they make a 1-to-1 salt. So that's our magnesium oxide product. So we've done the reaction. We have our magnesium oxide that we made. And you can see that the way the reaction happened, it's in the open air, and there wasn't anything to absorb or capture that energy that was given off that would make it easy to measure how much energy was given off. And so what we have to do is we have to figure out some other way of determining the enthalpy of reaction for this that does not involve doing this reaction directly. And so that's what we're going to do. We're going to do a pair of reactions in aqueous solution and make use of Hess's law to sum up the values for enthalpy changes we can measure and use that to determine the enthalpy change for this reaction that we just did without actually using this reaction directly. Okay, so we're ready to do our first experiment. And for this we're going to react magnesium metal with hydrochloric acid, an aqueous solution of hydrochloric acid. Magnesium comes in a number of different forms. The kind we're using is magnesium ribbon. And what it has is ribbon, probably about 1/8 of an inch wide, and it goes long pieces. And what we've done is we've taken that and cut it up into little tiny pieces, probably about a 1/2 an inch, a centimeter long, something like that. And that's what we're going to use for the metal. And the acid is 2 molar hydrochloric acid, which we made up from by diluting concentrated hydrochloric acid. Now, because we want to measure how much energy is released by the reaction, we don't want the vessel the reaction's happening in to absorb much of the heat. So we're going to do the reaction in a styrofoam cup. But before we actually do that, I want to show you what the reaction looks like by doing it in a beaker. And we're not going to actually measure much of the temperature change in any quantitative sense, but we're just going to show what's going to happen. Okay, so what we're going to do is we're going to take some of the hydrochloric acid, and we're going to do this and weigh it when we do it in a minute. And so we're going to record its temperature with our temperature probe. And then what we're going to do is we're going to have a stir. We're going to turn our stirrer on. And we're going to take our magnesium ribbon and just add it into the vessel with HCl. It's going to react and give off bubbles. This is making hydrogen gas. And the temperature is going to go up. And so what we're going to do is we're going to do this again using much more quantitative, careful means. But I just wanted you to see it before we do it. All right, so now we're going to do the experiment, but in a more careful fashion. We're going to start by weighing our reagents. So I'll do the magnesium first. Not that it needs to be. So I'm going to tear the weigh boat. And then I'll add some magnesium to it. I don't actually care how much it is, but I need to know exactly how much it is. Many of the experiments we do are like that. Feels good. Okay, so it looks like around 1.332 grams of magnesium. Okay, so now we're going to measure our HCl. And so the first thing we'll do is we'll put the cup on the balance and tear it. And then what I'm going to do is I'm going to measure out the HCl in a graduated cylinder, but we're not going to use this quantitatively. We're just doing that to get a feel for how much we want to add. We want to add a bit over 100 milliliters. So I'm going to add in around 120 milliliters. And then we're going to get our quantitative measurement by adding it to the cup and weighing it. So I'm going to add that to the cup. And then put it back on the balance. And so our HCl has a mass of 117.279 grams. All right, so it's time to do our reaction. Okay, so we're ready to do the real experiment now. So we have the cup here, we have our stir bar inside, and it's stirring. And we have the thermometer in here, and the temperature is a steady 23.3 degrees. So what we're going to do is we're going to take the thermometer out for a second, and then I'm going to add in the magnesium, and then put the lid on and put the thermometer through the lid. So that's the process, and our goal is to see by how much the temperature will increase. Okay, here we go. It's fizzling. Woo, that reaction's happening. Get the thermometer in there. Okay, it's going up a lot. Oh, get that lid on there. So temperatures will keep going up while the reaction's happening, and what's happening is the magnesium takes a while to dissolve, and so the reaction doesn't happen instantly. And so the reaction's still happening, and when the reaction's done, when the magnesium's all dissolved, then the temperature will stop increasing. It's going up by more than I thought it would. I was just guessing it would go up by like 15 degrees, but it's already gone up by like over 30. So at this stage of the reaction, I'm actually somewhat worried that maybe I added too much magnesium and it's going to get close to the boiling point of the water, which would, of course, ruin our measurement because then you'd be measuring how much energy it takes to boil the water. But we're hoping it'll level out well before then. We're almost up to 70 degrees. So, okay, it looks like our final temperature is 70.1 degrees. That didn't get dim because of that. 70.1 degrees. So we can now calculate our temperature change, and we know the mass of magnesium that was present. Those temperatures going back down again, that's because the reaction's not generating any more heat, but the cup is getting cooler just like your coffee cup would get cooler when you leave it out. Okay, we're ready to do our calculations. Okay, we're ready to repeat the experiment now, but instead of magnesium, we're going to use magnesium oxide. Our magnesium oxide is purchased from Flynn Scientific, one of our chemical suppliers. And so we're going to do basically the same thing. Okay, so we're going to weigh our magnesium oxide. So we're going to put the weigh boat on and tear the balance and add it in. Magnesium oxide is a white powder. We want about around a gram. That's nowhere near enough. That's nice and musical. Will that do? That's a little more. Okay, so our magnesium oxide is 1.043 grams. And now we'll weigh out our acid, our HCl solution. So we will put the cup on the balance and tare it. That little cup weighs around 8 grams. All right, and then again we'll use about 100, 110, 120 milliliters. So I'll measure out roughly in my graduate cylinder. Then we'll add it to the cup. We'll take the cup off the balance because we don't want to, if we spill, we don't want to spill acid on the balance. Put it back on the balance, and our acid weighs 110.180 grams. Okay, so we're going to repeat the experiment now. We're going to take the acid and put it over here. Put the stir bar in. We'll start stirring. We will get a temperature reading before the reaction. That's 23.1 degrees. And now we'll go ahead and add our magnesium oxide. Put the lid on. Add the thermometer in. And watch the temperature rise up. So we'll do that until it stops changing. So after some time, the reaction is done, and the final temperature is 29.9 degrees Celsius.